All right, Brent Porcio, 3x pitch BioMetric Analysis here of Rene Sanchez. Got him in 78 miles an hour coming out of leg lift. Not taking the hips forward and down at the same rate, basically far enough. Like the force vector right before leg drive is way too vertical. So if I use a drawing tool here, I can kind of show where ideally the vector should be, and that's the ankle to knee. So this right here needs to be something more linear, something out here pushing against a hip position here, because this energy coming in that angle would help drive the hips towards the target. At this angle, we're going to get, at that angle, it's just too vertical. So coming out of leg lifting before leg drive, it's too vertical. So when you go into some drive here, it kind of pushes you up. You can see your body wants to go up off the ground, and we want to continue to move down the mound. The mound is declining, so we have to move down and generate force down the mound. So this is going up. So it's taking that hip more forward and down the same rate, and at the end of the day, you need to make sure your hip mobility can support that. If not, it's not going to want to happen. So as you can see, there is a bit of a push, and it starts to lift, and then you kind of turn it over, because ideally you don't want to jump. So the turning over is important too, because that helps the femur internally rotate and the hips start to come around. And you see it here. You see the hips coming around. So decent sequencing, good sequencing once the hip comes around. It's just the initial energy out of the ground is too vertical. So if we go into look at the sequencing, this is how the rotational sequencing is working. You can see when the femur internally rotates here, the hip starts to come around. That's the red line. That starts to come around. But you can also see the glove pulling with it, which is the blue line, which is peaking right here, which means it's helping drive rotation. Problem is when the glove side helps drive rotation, it causes the trunk to either go early or to over-rotate, and it doesn't get a lot of that linear momentum that you generate through your stride moving the trunk forward. So the trunk wants to just spin. And you can see the blue line is higher than the red. That means the glove is actually pulling harder into rotation. But like I said, you have some decent sequencing, because you can see the hip here peaking, and then you see the trunk right after peaking, but there's somewhat of a delay, and that's the green. So you do want that. We just want it a lot bigger. We'd like to see maybe the hip peaking back here, and then the trunk peaking here, and then ideally then the arm would come after that. But you see how quick the arm is coming? That's because the trunk is just more than likely going to rotate. So once the trunk opens up, it better release the pitch. If not, the energy is going to shut off. As you can see here at pitch release, the trunk doesn't really go forward. So if we look at what's called the linear sequencing, or kinematic sequencing, this is now how is the hip, trunk, and arm moving forward. You can see the glove, which is the blue line, really throws out here, which there's a lot of, the glove is helping move things forward. Then you can see right here is probably where the hips peak moving forward towards the target, and you can see the trunk is right after it. So there's really no separation in a linear sequence, which is really most important, is that linear sequence. And you can see when the trunk starts to come around, the linear energy just shuts off. I mean, down here at pitch release, there's literally no forward movement in that trunk, and we'd like to see it just coming out of a big forward peak, and it's well out of a peak. So we don't have that forward momentum, which is not only significant to velocity, but also keeps the arm healthy as well. So if we look at the orientation at pitch release, the trunk is at a 2-degree position at pitch release, when a high velocity pitcher would be at a 45 or 50 degrees. So considerably less forward trunk movements in here with Rene, which is really preventing a lot of velocity here. So how do we get that? We got to get that linear drive initially. If we can get that linear drive through the hip, then that should carry more linear energy. I think the timing of the movements isn't too bad. Just the glove's just trying to help out, but I like the timing. The arm is even cocking a little late, which I like. There's just no linear energy because of the initial movement coming out of leg lift and the poor force vector and the back leg at drive. Not only that, we don't see the front leg really help out. The front leg stays bent, which the front leg driving back can also really help support the linear movements, the linear trunk. At pitch release, the trunk is contralateral, which is leaning to the glove side, 28 degrees. 25 gets excessive to where the basically what a study shows is the velocity stops going up, but the torques keep going up. And once again, it's a lot of because there's more rotation in that trunk than there is linear power, linear force. So I think that's the key thing, working on the back leg force vector, keeping the hips moving forward and down the same rate, powering more linear power through the hip, and feeling that transfer the trunk forward. That's going to take mobility work and power work, and then teaching the body that through the mechanics to really make that happen.